Let's discuss conductor sizing and grounding for a generator transfer switch. We'll base this discussion on the 2002 National Electrical Code. Firstly, let's address conductor sizing. The code dictates that the ampacity of the generator connection leads must be at least 125% of the generator's full load current. In the example provided, the generator's full load current is 55 kV divided by 0.707, representing the power factor. This calculation results in 78.0 amps. Consequently, the minimum ampacity of the conductors is 78.0 amps multiplied by 1.25, which equals 97.5 amps. Referring to table 310.15b16 in the NEC, 300 kc copper conductors have an ampacity of 263 amps at 75 degrees Celsius. Therefore, these conductors meet the minimum ampacity requirement. As for the neutral conductor, it carries half the generator's full load current. In this case, that's 78.0 amps divided by 2, resulting in 39.0 amps. Again, consulting table 310.15b16, 1/0 copper conductors have an ampacity of 140 amps at 75 degrees Celsius, satisfying the neutral conductor requirement. Secondly, let's consider grounding. A generator must be grounded according to NEC Article 250. The grounding conductor must be sized adequately to handle the fault current that the generator can deliver. In the example, the generator's fault current is 55 kV divided by 0.133, representing the generator impedance. This calculation yields 413.5 amps. According to table 250.122 in the NEC, the minimum grounding conductor size is 2/0 copper. Thirdly, let's look at the connection. The generator should be connected to the transfer switch strictly according to the manufacturer's instructions. A critical point is that the generator must be isolated from the main power supply when the transfer switch is in the generator position. This prevents backfeed and potential hazards. Furthermore, the generator must be properly bonded to the electrical system to ensure a safe and effective ground fault path. Fourthly, here are additional considerations. The generator must be equipped with a circuit breaker or another appropriate overcurrent protection device to protect against overloads and short circuits. The transfer switch itself must be correctly rated for the generator's size and voltage to handle the load safely and reliably. The generator should be situated in a well-ventilated area to prevent overheating and ensure proper operation. Finally, the generator must be maintained diligently according to the manufacturer's instructions. Regular maintenance ensures optimal performance and longevity. In summary, correctly sizing the conductors, implementing proper grounding, following manufacturer's instructions for connection, and adhering to additional considerations are paramount for a safe and effective generator transfer switch installation. Remember to always consult the latest edition of the NEC and local codes for specific requirements and guidelines. It's also crucial to engage qualified electrical professionals for installation and inspection to ensure compliance and safety.